Hello there. Welcome to Slow Ride Labs, where we're rocketing towards the future at 25 miles per hour. Today's an exciting day to stop in. We're hoping to discover whether the average person can sit through a 10-minute video about science. Do we have any buntonium over there? Excellent. We've been on the road for many weeks now, talking with people about changing climate patterns. Many people have told us that they have seen some strange changes in the weather, but they have questions about what's going on or why. Well, today we're getting off of the streets and into the lab, where we are going to talk to some New England scientists about what they think. Sodium concoct, please.
I think we made this one a little too strong.
Could you introduce yourself, say where we are, what you do, maybe some of the research that you're working on right now?
Sure. Yeah, my name's Ray Schmidt. I'm a physical oceanographer at the Woods Hole Oceanographic Institution. We have a lovely place here on Cape Cod.
I'm Sarah Cooley. I am a researcher at Woods Hole Oceanographic Institution. My background is in ocean carbon chemistry, so I look at how the ocean takes up carbon dioxide from the atmosphere. And right now my area of interest is primarily ocean acidification.
My name is Jeff Donnelly. I'm an associate scientist at the Woods Hole Oceanographic Institution.
Well, I'm Lloyd Kegwin. I'm a senior scientist at Woods Hole Oceanographic Institution. I've been here 32 years, studying various aspects of the role of the ocean in climate change.
Woods Hole is a little fishing village that's sort of become a mecca for ocean sciences. The Woods Hole Oceanographic Institution's here, the Marine Biological Labs here, the USGS, the US Geologic Survey is here, Sea Education Association, so it's just basically a melting pot of ocean science and education in a little fishing village in New England.
What made you decide you wanted to do this work?
I was always fascinated in the natural world and exploring it, and became clear that this was a way to sort of scratch that itch and ask and then answer some fundamental questions about how the Earth works. Sort of, it's an extension of me playing in the mud puddle when I was a kid, I think.
Well, for me, it's like solving a mystery. You see some aspect of nature and you try to understand it.
It's something new every day. Every time I look at a sample, I'm looking at something that no one's ever seen before. And I've had a career doing it.
Could you give us a short primer on what climate change is and what we know about it?
Okay. The climate's always changing. It's been changing for billions of years. The difference now is that we're actually playing a role in that. We're modifying the chemistry of the atmosphere and basically changing the radiative balance and augmenting the natural climate change that's already occurring. What it comes down to is that there's some basic physics. We know how it works. We know that greenhouse gas in the atmosphere holds in more radiation. We've known it for 200 years. And for the last 100, 150 years, we've been pumping huge amounts of these gases into the atmosphere. And then even in the last 50 years, people were making these predictions about the planet's going to warm. And lo and behold, it is. And so it's not sort of us going back and trying to make up reasons why this has been the warmest year on record kind of thing. We knew from fundamental physics that this was a process that was going on. And now we have the data to actually show that it's happened. And so from a scientific perspective, it's not surprising at all that we're seeing the changes that we're seeing.
Humans have really irrevocably changed the Earth, and the climate change that we're seeing now is a real consequence of that. And I think what convinces me is the data sets that really show that temperature has been rising, the precipitation patterns, distribution patterns have been changing, and the fact that when we apply global models and forecasting models to it, we can't replicate those trends if we don't include people in the mix. Those are the things that convince me that climate change is a real thing, and we probably should be paying attention to it if we're at all concerned about the longevity of humans on the Earth.
Is it really scientifically sound to be able to say, we've had a bunch of heat waves over the last few years, it didn't snow at all this past winter, therefore climate change is happening?
I mean, it sort of gets down to the point of what's weather and what's climate change. I mean, climate's sort of a long-term average.
There are lots of cute anecdotes like you buy clothes for the climate, but you dress for the weather.
Weather's the day-to-day variability, and climate's the longer-term average.
When you start looking at the longer time scale, sort of decadal and centennial scale patterns, that's when you're talking about climate, and that's when you observe these longer-term trends. And you know, I think back to when I was a kid 30 or 40 years ago, and you know, there was a lot more winter. You know, I mean, we would actually have, you know, lots of snow and ice in the ponds, and you know, and that's, my kids don't get that. And you know, that's clearly a product of this warming that we've seen over the last couple of decades. You know, is it possible we'll still have a winter or two where it'll be cold enough to get, you know, ice in the ponds and lots of snow for the kids to play in? Sure, it'll certainly happen. But it's not going to happen at the, you know, at the rate it did, you know, 30, 40, 50 years ago.
If climate were not changing, you'd expect to break cold records, temperatures, as often as you break warm record temperatures. Well, for the past couple of decades, we've been breaking warm, high temperature records twice as much as we break cold temperature records. This past year, it's been 10-to-1, warm records versus cold records. There's a lot of people that think, oh, this is just normal cycles of climate because there's been ice ages in the past and all this stuff. Well, that's not true at all. We understand those normal cycles of climate. We know that right now we should be heading into an ice age, but we're not. So we're seeing these patterns of change in the climate system that are just very, very clear, perfectly consistent with global change models. And you know, to me, it's just appalling that society won't face up and start to deal with these issues.
How do you think that people, just kind of the everyday person in New England, could be impacted by climate change?
I think extreme events are the problem. I mean, extreme events like that hurricane that was already a tropical storm by the time it hit the mid-Atlantic states and New England last August or September? I don't remember. You know, it caused enormous damage. I mean, it was a massive storm. It didn't happen to have hurricane punch anymore, but it you know, it occupied such a huge area. The predictions are more extreme events. So, you know, the mean change in temperature might end up only being a couple of degrees, which, you know, if the amplitudes didn't change, you might not even notice it. But if the extreme events get more extreme, then it's going to affect everybody one way or the other. But it is funny, all the predictions that people have made seem to be coming true in the past year or so.
We think that it's very likely we'll have 3 feet of sea level rise by the end of the century. You know, that's not so far away. Some youngsters today are going to live to see that. You know, for an average coastal community, they may have a seawall and then a beach. Well, the beach is going to be gone, and they'll be right up against the seawall, and they'll be losing the roads. So it's just going to be a huge, expensive headache for every coastal city around the world.
The vast majority of the scientific community the earth science community is really in agreement that climate change is happening, and I think people are more divided on what we need to do about it. Some people think we can engineer our way out of it, and other people think that we need to just basically roll back everything that we've done in the past 200 years, and then pretty much everybody else is somewhere in between.
You know, there's a community out there trying to delay any societal response to this serious scientific issue. But you know, it's just like smoking. I mean, the doctors pointed out, hey, if you smoke, you're going to get lung cancer and die. We're just saying the same thing to society. You keep burning fossil fuels, you're going to overheat the climate system, and it's going to have some adverse impacts. And it's playing out right before our eyes. We all know it, but nobody wants to do anything about it because we can't give up smoking, we can't give up fossil fuels. Interestingly, there's always a small core of so-called scientists who like to deny these things, and it's the same people. A lot of the same people who were fighting the fact that smoking causes cancer are the same scientists bringing you fossil fuels don't hurt the climate system. It's just amazing.
In the United States, as climate change has become sort of a hot button topic, and many of the researchers working on ocean acidification in the United States have been a little bit nervous to really tie things closely with climate change because of the paid denialist movement that is happening with climate change. You know, there's documented like paid money trails going between corporations that have vested interests in business as usual and people who are outspoken critics who go out and attack anywhere they can.
You know, society's been hoodwinked by the fossil fuel industry. The thing that hurts is we're putting out the facts, but people think we've got some kind of agenda. We don't have any agenda. We're just saying, hey, the climate system's changing. What are we going to do about it? We know why it's changing.
What if climate scientists are wrong? What if people have nothing to do with climate change?
What if they're wrong? The evidence is overwhelming, but rather than sort of focus on who's right and who's wrong, who's at fault, let's just go to the data, right? We know from the instrumental data, from the temperature records, from the tide gauge records, that not only is sea level rising at 3 or 4 times the rate as it has in thousands of years, but the temperature is rising considerably. Regardless who's at fault, we need to prepare for climate change, even if it's natural, right? Whether it's our fault or their fault, or it doesn't matter, really, it's happening. Let's prepare for it, let's deal with it, let's try to mitigate the impacts, sort of thing. And that's the frustrating part. We can all observe it. You know, everybody's talking about how warm it is and how we don't get ice in the ponds to go skating on anymore in the winter, and everybody's observing these changes in their own lives. But the debate about it gets so politicized, and what we really need to do is just observe what's occurring and prepare for more of the same sort of thing. But instead, we're spending all of our resources and energy sort of fighting about whose fault it is.
Actually, it would not be expensive to change the system. It's just choices we make. Look at the world population, where it's 7 billion people. It'll be 9 billion people in a decade or two. And everybody wants to drive a car. We're on the cusp of huge changes, huge changes.